This video is going to show you how to change from rational exponential form to radical form and back the other way. So here are the rules in this gray box. A to the m over n, that's in rational exponent form. That's really just a fancy way to say a fraction in your exponent. This and this are your radical form. So if it has a square root or a radical, that's radical form. If it has a fraction in the exponent, that's rational exponential form. So you're going to be moving from one form to the other. Notice that the numerator becomes your exponent and the denominator becomes your index or your root. That's always where those pieces go. So let's try these below. So number one, we have radical form. We want to change it to write the same thing using rational exponents. So our base is y, so we would start with y, and then we need to figure out what the exponent and the index are. So the exponent, if there's not one, remember that's understood to be a 1. And if there's not an index, that's understood to be a 2. So your exponent is 1, your index is 2, so your rational exponent is 1/2. Again, the exponent comes for the numerator, and the root or index comes for your denominator. So y to the 1/2 is what we're looking for here. Same idea for number 2. Your exponent is 3, your index is 7, so this would be rewritten as x to the 3/7. For the next 6 problems, we're going to be writing in radical form. So we want to use a square root or radical to simplify these. So 1 is the exponent, 2 is the index, 9 is the base. So I like to start by writing the radical and the base and then filling in the pieces. So this 1 is the exponent and the 2 is the index. I don't have to write the 2 as an index there. It's understood to be a square root if nothing is written. And I don't have to write an exponent of 1. That's also understood if there's nothing written there. So what I really want to write is just the square root of 9. And then I can simplify. So the square root of 9 is 3. If you didn't know that, remember that you can use a factor tree and break this down into prime factors. And since it's a square root, you're looking for pairs of numbers. We have a pair of 3s. We have no leftover numbers, so that just comes out as a 3. Okay, number 4. We have 32 to the negative 2/5 power. So in this video, I'm assuming that you already know how to simplify square roots or radicals, and I'm also assuming that you remember how to handle a negative exponent. So if you don't know how to do those things, you may want to go back and find a previous video covering those topics. So for number 4, remember that if you have a negative exponent, you're taking that base and you're moving it to the other side of the fraction. So right now it's not a fraction, but we could write it over 1. And that 32 would be moving to the denominator. So this is going to become 1 over 32 to the positive 2/5 power. So when you move it, it changes the sign on your exponent. Now we want to rewrite it in radical form. So we're going to have 1 over, we're going to have a radical, and 32 is our base. The denominator is your root. So we're going to put a little 5 here. So we're looking for the 5th root. And the numerator is our exponent. So we're going to put that out here. I highly recommend finding your root first. So if we're finding the 5th root of 32, we can make a factor tree. 16 times 2, 4 times 4, and then the 4's break down into 2 times 2. Since it's a 5th root, we're looking for a group of size 5. We have 5 2's, no leftovers, so that's going to just be 2. So this is 1 over 2 squared, which is 1 over 4. I'm running out of space here. So number 4 simplifies to 1/4. Number 5, we want to rewrite this in radical notation. So our base is 27. The exponent is 1. The root is 3. I don't have to write the 1 exponent, but if I did, it would be there. So I want to find the cube root of 27. So I can use a factor tree. 27 is 9 times 3. 9 is 3 times 3. We have a group of 3 3's. So the cube root of 27 is 3. We are going to go ahead and cross off number 6. It's overly complicated. We're not going to look at that one. We can look at number 7. So number 7, we have negative 16 to the 3/4. This one is not, there's not as much involved in this one as the previous one because the previous one had negative 8 in parentheses. So in the previous one, negative 8 was your base. And then you have to keep in mind what happens if you have a negative raised to certain powers and the root. If you don't have parentheses around it, then the only thing raised to that power is the number itself, not the negative. So the negative just comes along for the ride. So this one is probably more reasonable for the scope of our class. So we'll look at this one. So we have a negative just coming down with it. We have the root and 16 is the base. The exponent is 3 and the index is 4. So we want to take the 4th root of 16 first. So the 4th root of 16, if I make a factor tree, this is 4 times 4. This is 2 times 2, and this is 2 times 2. So we're looking for a group of size 4. So we have 4 2's. So a 2 is going to be the 4th root of 16. And then we can cube the 2. Again, we're just bringing that negative down. So we end up with negative 8. Our last example, number 8, we have 9 to the negative 3/2 power. So first we want to deal with that negative exponent. So we'll be moving this down to the bottom of the fraction. So this will be 1 over 9 to the positive 3/2. Next we want to rewrite in radical form. So we'll have 1 over the square root of 9 cubed. So the exponent is 3 and the index or the root is 2. That's understood to be a 2, so I don't have to write that in. The square root of 9 is 3. And then 3 cubed is 27. So this one is 1 over 27.